Binary logistic regression with categorical predictor in JAMOVI. Binary logistic regression is a statistical method that can be performed to find out whether there is a relationship between two variables. One of the variable is called the outcome or the response variable or the dependent variable, and the other variable is the predictor variable or the exposure variable or the independent variable or the explanatory variable. For binary logistic regression, we need two variables. One of the variable is the outcome and the other one is the predictor. The outcome have to be binary. Binary mean that it have two levels in it. Whether you have a disease, no diseases, smoker, non-smoker, have diabetes, no diabetes. The predictor can be a continuous variable that is measured at interval or ratio level. It can be binary variable that consists of two categories, or it can be nominal variable, which is called categorical variable that consist of more than two categories or three categories and more. So it has to be either more than two categories or at least three categories to be called a nominal or multinomial predictor. And the predictor could be also ordinal, which is a categorical variable but with order in it. So the objective of performing binary logistic regression is to find out whether there is a relationship between the predictor and the outcome, and whether the predictor can explain the variation in the outcome. Here in JAMOVI datasheet, I had inserted 200 cases as shown in this window. There are two variables. The first one is smoking and the second one is cancer. So the smoking variable is categorical variable as it has four levels in it. The first level is non-smoker. The second level is smoking cigar. The third level is the smoking pipe. The fourth level is smoking cigarette. So there are four categories in this variable. So it is categorical variable or multinomial variable or nominal variable. It's all the same meaning. The second variable, which is cancer, is binary or binomial because it has only two levels in it, either yes or no, whether they have the cancer or no cancer. So here we have an outcome which is binary, cancer, and a predictor which is multinomial, which is smoking. To find out whether there is association between smoking and possibility or probability or likelihood or chances of developing cancer, then binary logistic regression can be performed. The test depend on the outcome that have to be binary, and the condition is satisfied here. So we have outcome which is binary and a predictor which is categorical. Before we proceed and do the binary regression, let's look at some descriptive statistics by clicking on the exploration here and then tick on descriptive. In the new window here, drag the smoking to the variable section or variable sections and the cancer to the same box, and then tick on the frequency tables here. And for statistics, since we have both variables are made up of or consist of categories, then we don't need the median, we don't need the mean. For the dispersion, we don't need standard deviation, and we'll keep the rest. Looking at the output here in the descriptive, the first table shows that there are 200 cases and no missing cases in both variable. For smoking, the minimum value is 0. 0 is assigned for those who do not smoke. and 3 for those who are in the last category, which is cigarette smoking. So 0 for no smoking, 1 for cigar smoking, 2 for pipe smoking, and 3 for cigarette smoking. The second table shows the frequencies. There are 50 cases in each category for the smoking habit. For the third table, it shows the frequencies of cancer. There are 100 cases of cancer, and there are another 100 of cases of not having cancer. To find out whether there is association between smoking and cancer, then we need to do binary logistic regression. To do that, click on regression here, and then scroll down to the 2 outcome binomial regression test in the new window here. Drag the cancer, which is the outcome, into the dependent variable. Drag the smoking, since it is categories, drag it into the factors, since it has 4 levels in it. There are few options to select from here. Model builder, no need to select anything. For reference levels, since we have here 2 categorical variables, the cancer and the smoking, the reference category will be used is the no, those who do not have cancer. So comparison will be to the individual with no cancer. For smoking, there are 4 levels. We can select any of these as a reference group to compare to. We'll stick with the non-smoker as a reference group. Assumption check or checks, not look at it at this stage. For model fit, tick on the Cox Snells and tick on the next one for R square. And for a model coefficient, select the odds ratio here and the 95% confidence interval. For the estimated marginal mean, no selection. For the prediction, again, probably classification table, but we will not look at it at this stage. Looking at the output from the binary or binomial logistic regression test, there are multiple tables produced. The first table is for the model fit measures. Looking at this value here, which is the R square, it shows that 11.7% of the variation in the outcome can be explained by smoking habit, whether you are a smoker or non-smoker, smoking cigar, cigarette, and pipe. So 11.7% of the variation can be explained, variation in the outcome, which is a possibility of getting cancer, can be explained by smoking. Moving to the second table, which is a very important table for model coefficient with the outcome, which is cancer. Again, predictor here is given. Intercept, we will not talk about intercept in this section. For smoking, there are 3 categories. All of them has been compared to non-smoker. So cigar is compared to non-smoker, pipe is to non-smoker, and cigarette to non-smoker. Looking at the footnotes here, those who have cancer given yes, and those who have no cancer no. So cancer, here we are looking at possibility of developing cancer. The estimate is given for each output, which is the coefficient, the standard error, z-score, the p-value, the odds ratio, and 95% confidence interval for the odds ratio. Here we have 2 levels of significance to check the significance, the p-value and the 95% confidence interval. P-value will be set at less than 0.05, and anything less than 0.05, then this is significant. Here is shown that all the 3 categories, there is a significant association between smoking and developing cancer. And for the 95% confidence interval, all the odds ratio fit within the lower and the upper limit for the confidence interval. So from this table, there is a significant association between the predictor and the outcome. The way to interpret this table is that those who smoke cigar have an increased odds of 2.7 compared to non-smoker. Or in another way, those who smoke cigar have a higher chances of developing cancer, or more likely to develop cancer. For the second category, which is pipe compared to non-smoker, those who smoke pipe have an increased odds of 2.5 compared to non-smoker. So smoking pipe increases the probability of developing cancer. For cigarette category, those who smoke cigarette have the highest likely of developing cancer compared to non-smoker, as the odds is 6. So there is an increased chances or increased likelihood of developing cancer with smoking any type of tobacco here. Those who smoke a cigarette have the highest chances of developing cancer. So this is the way to perform binary logistic regression with an outcome that is binary and a predictor that is categorical in JAMOVI. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, JAMOVI, R Statistic or Statistics, GraphPad, Prism, GPower, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, JAMOVI, R Statistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.